So here we go. So welcome to Thursday, December 17, the last official day of class. You're working on your exam. You have it in your hand, essentially, and you're going to hand it in by tomorrow night, 11:59. But I want to make sure everybody has a chance to ask all the questions they can. I won't answer questions specifically about the exam, but if you need something clarified, no problem. And the general rule is you ask whatever you want to ask. If I can't answer it, I'll tell you politely, but I'll help you wherever I can. Any problems from the book, of course, we can always do if you have similar problems identified. So what can I do for you?
I actually don't have anything at the moment.
Okay, so I'm just hanging out, organizing papers in my noisy alternate room on my tiny desk, and you're welcome to hang out here as long as you want. I think, I can share my picture with you because it looks like you have a similar setup to me. Maybe you got this little thing from Walmart just hanging your phone. I don't know. There's some kind of wire in front of you on your right hand shoulder. Is that holding your phone?
Oh no, this is a pop filter for my mic, so that way when I pop.
Good. Yes. So if I had to take another step, yeah, I'd get a better mic and stuff like that. But I'm just holding my phone 9 inches over my paper right here with some kind of arm from Walmart.
This was my Christmas present to myself, so.
Yeah. So you relax, do whatever you want. Pop in with a question when you want to. I'm just organizing, grading papers here.
Sounds good. Thanks, Professor.
No problem.
Professor, for the first question, do we need to state where the zeros are? Or I should better say where the equation would be undefined. Hey, Professor.
PNG person asking me about healthcare because you'll end up enrolling in a healthcare plan on the day you start. And then each year they have the annual benefits enrollment in October, so I can switch plans then. And then if you experience a life change, such as a parent or birth your child, you have options to make a change at that point too.
Almost standard procedure in law right there.
So,
We can go over that means you have time to go over the options in detail with you.
yeah.
Nobody's healthcare. Things are perfect right now, but at least you also have substance. Next one. Do they have any paper towels in this meeting? What are your tickets for?
They're for 1 o'clock, so we'll be here at like 12:40.
So it's a Gramercy?
Yeah. Andrew got so looks at their new mattress and they're literally just rectangles of bone.
Yeah, that's somehow. Oh, I'm sorry, Jacob. I'm just conversing with someone else. Don't mind me.
Oh, you're fine. I had a question about number 1.
Go ahead.
Do I need to state where the equation is undefined?
And you're talking about number 1 on the test.
Yes.
Let me pull it up so we're looking at exactly the same thing. 19 exam 2. Got it. Instructions, blah, blah. Okay, so let me open that up in front of us. Where is it? So we're looking at a rational equation. So that's what it was stated.
Right.
And solving always means the same thing. Solving means find the number that makes the two sides equal. So you would be reading in your book right now that sometimes you have solutions that are false or solutions that don't make the two sides equal. So you're certainly worried about any places where the denominator equals 0 because you'd certainly have to reject those. You don't have to say anything here, but very common error in this situation is someone giving me an answer that's unacceptable because one of the denominators would be 0. So you should always, I would say the book would tell you, I'll tell you as much as the book would tell you, that you should always check locations where the rational expressions would be undefined. You should always make a note of that. Whether or not that interferes with solving this one, I don't know. But yeah, you're thinking safely. You're trying to think carefully.
And you don't have to answer for the specific question, like just in general. How would you check an equation like this? Like I said, it doesn't have to be the specific one, but
Oh, sure, you could check in a very ordinary way. Say, if you told me that 24 was the answer, I would put 24 in place of each x and see if the left side equaled the right side. Now, 24, it probably doesn't surprise you. 24 would not work.
because I'm just
I
wondering,
mean,
just 'cause-
physically checking just means you can insert and you show me that the two sides are equal. That would be the safest way to check.
because for answer like this, you wouldn't just get like a whole number answer. So that's why I was just wondering.
No, not necessarily. I mean, it could, your answers here could be fractions themselves. And sometimes that looks intimidating to insert a fraction into the fractions, but you can still, one step at a time simplify it. So I see lots of problems like this where the answer is 3/7 or
So you
something.
wouldn't have a variable as an answer?
No, your answer here should be a number.
Okay.
It's x is a placeholder. We'll look at the sections where you're actually doing these. And your goal is to find a number that makes both sides the same equal number. And you're looking at the screen I'm looking at, right? The 2x over x minus 6?
Yeah.
Now the answer's got to be, if there are any, sometimes there are none, but the answer would have to be a number.
Okay.
No problem. Let me record this just for anyone else.
Oh, I see where I went wrong. I misunderstood the directions. I combined the expression instead of solved it. Okay.
Oh, that's a serious problem. So if you did that, I'm glad you see that. No, yeah, and those problems look so much alike. With one pen stroke, I could have said that minus instead of equals. And it's very common for people to work very hard to simplify the answer when simplifying was never what was requested. So make sure whenever you look at a problem like that, are they asking me to simplify an expression or are they asking me to solve an equation?
Ah, okay.
hang on, I'll be right back.
I heard back from Billy from the program advisor, and I don't know, maybe this means more to you than it does to me, but it seems like they're discouraging people who want a PhD for big science.
I can understand that. I can explain to you why, but that's a matter of your choices. I think they're trying to say to you that if you're headed for a PhD, you don't want to take any shortcuts. You want full basic preparation. And this thing is more, maybe the psych thing is more for like, I've got a master's degree, what I did. That doesn't make either of those choices wrong. It also doesn't, I mean, I think you should talk to the assumption too, like, well, I think you were on target when you said earlier. Because it's common that something goes out in the industry that finds some really interesting problem, comes back to work on it. And a doctorate or a master's, I think that's often the case for your guys, but I don't know. Are you trying to keep the door open?
Yeah.
Yeah, and you're talking about graduate school. And I think you want to have a conversation with us, with typical time required. How do I find out, what areas of interest are available? Yeah, I'm really gonna have a deep conversation.
So maybe science isn't for you, but you can think about it for a day or two. We got 5 people crammed into one apartment here. I guess I'm not giving away any personal information to anybody who's here or recording, but all 5 of us are working classes or teaching. It's just a crazy time.
back.
Yeah. She said, I'm sorry to hear that, because I thought we'd be a really good fit, and we just put so much work into this. They asked you what your reasoning is. for safety. It's hard. She doesn't want to spend as much money. She said, like, oh, I'm sorry to hear that, because I thought we'd be a really good fit, and we already put so much work into the search. And I asked you for your reasoning because of its safety. I'm open to looking in an area closer to downtown. I was hoping to have a roommate, being that I don't know many people in the area.
You can respond to anything. But here the door is no longer open.
Yeah, no, I.
You just, I need, everything you can come up with, she could come up with a counter, but you guys would just be spending time talking about something
Yeah.
that's in an alternate universe.
Yeah.
It just wasn't gonna work out for me, I'm sorry.
Yeah. I'm still going with her.
Okay, that might help people.
Oh, yeah. Yay. That's awesome.
So you a what? Two.
Well, I need to start seriously figuring out exactly where everything is going to fit. Because,
Well, but go to the county zone.
yeah, I need to get a constant point. With having done all of the intellectual breadth and stuff before, basically, I've been really technical semesters. And I still have a couple really chunky classes to go through, so. I think
But I think future directions. Yeah, it's wrong. Thinking it's a trip. That's it. Or would you like to continue if you want to continue? Would you like to continue?
well, I mean, if I were for a graduate degree, I would leave,
Leave for the there.
leave, but
That's a situation. That's a word in the lab.
Okay. Yeah. And I just leave it to what? I can only receive from contacts only, so it's possible that they can't see me at all. capacity of a 1 bedroom, so like I wish I could told her earlier, so I didn't waste her time. But I'm just trying to come down here and see the area. Come to that conclusion.
And then you love.
Yeah, one time. Too much. Ready?
I just have to go back.
Okay, so we need 5
Oh, silly, silly. Why do I have to think?
Oh. Kiara was like, I'm really sad to hear that because I thought we were a good man. We got so far in the search. And I asked why, because with safety, I'd be open to going closer to downtown. And I told her like I just talked to my parents about like the privacy of a 1 bedroom, the flexibility, and that's what that's gonna.
It seems like the subs program is discouraged for those people who want to get a PhD, which means I need to decide kind of immediately before I would enroll in subs. I would have to know which way I'm going. Yes.
That's what I was afraid of. You do that, I'm not, you know, do we come back and do it? I believe that too.
Hey, Professor.
Okay.
Go ahead.
For the second question, when you get the answers and you type them back into the original equation, you should get 0, correct?
So Danae just.
I'm looking, well, you must, you must. And, but if you've already approximated, maybe you get an answer that's close to 0. Now, remember, before you approximate, you do have exact answers. You can check approximations on a calculator or Desmos, but theoretically, in the ordinary sense, yes, you must get 0 if you insert your proposed solutions.
Because I believe I did everything right, but when I type when I type the numbers back into the equation, I don't get 0.
You get near 0, or you get 15, or what?
One of them I get -2, and another one I get -27.
No, that doesn't sound good. Have you tried graphing this and seeing where the solutions would be? I mean, at least it would give you a neighborhood that, maybe in your simplifying and you used completing the square because completing the square was the instructions.
Right.
Have you tried doing it with a quadratic formula just as a side-by-side safety check? You don't have to do that on the paper, but you could still use the quadratic formula and see if it matched.
All right. Thank you, Fred.
Or graph it. Yeah.
Yeah, I'll graph it and I'll see what I turn out.
Okie dokie.
Oh, I see what I did wrong.
Yeah, you should always, regardless of the problem, if you can look for 2 ways to do any problem, that always makes you feel better.
The problem
Maybe, and sometimes
Oh,
helps you find mistakes.
I added the final number instead of you divide by 2 and then you square it. I added the number after I squared it instead of just divided by 2.
Ah,
Professor, do you know what section number 3 came
We could probably make a good guess. Let's pull up problem number 3. Just so we're looking at this. Okay, let me share the screen. This is something about a ball or a softball or some type of projectile flying through the air. The problem was not any one problem in the book, but I can tell you the sections where they did ones like this. Let's see. It is about quadratic functions, and it is probably applications of quadratic functions. So we'll write this down. From where? Okay, so there's all kinds of questions like this in section 8.7, example 1, example 2, example 3, and then he does more, example 6 and example 9. Any kind of these motions any kind of these problems that we call projectile motion. So anything that looks like that, projectile motion formula from section 8.7. Now, I did not phrase it like any of the problems in there. So you're just trying to solve for a certain height if you know that the softball's been in the air 3 seconds. So, where I got that equation from would have been one of these formulas, but I wasn't imitating any problem necessarily in the book, but we'll write down, see example 1, 2, 3. Let me get this on the camera for any future people. See examples 1, 2, 3, then again 6. And then he does several problems in the exercises like this, problems 9 through 14. But again, don't go, you're welcome to do all those problems, but don't go too deep into that, because this is not one of those problems. And it's just, using the formula in a different way. So I would just take the problem strictly at face value. If this is the T, what is the H? That's what it's saying, I think. Use this formula to find the height H that this softball will be at 3 seconds after it's thrown into the air. So what is H when T is 3? Or just go straight ahead like that.
So would I have to show the work of going through the formula, or would I just be able to graph this and give the answer?
Well, let's see. The instructions are show how to use this formula. Theoretically, you could say graphing is using the formula, but I think really you want to take this formula and manipulate it. If you want to provide the graph as like a verification or safety check, that's fine. If you provide the graph only, then not you, but anyone who did that, you'd have to be giving me a very good graph and know exactly why that's the graph. The graph isn't hard, but it's different maybe than some you've seen. I think it's
Yes.
fastest way is to manipulate that formula. I mean, the
'Cause
graph
like you s-
graph is going
Go
to
ahead,
give
I'm
you
sorry.
even an estimate too. Maybe it doesn't give you the exact answer. I don't know. I do both, make sure they match.
Because like you said, we've always done problems where we were figuring like where we knew the height. I'm not asking for specific answers here, but
Hmm.
because we've never done one where we've had to solve for the time.
No, you're
you
not
know,
solving for time. The time is 3 seconds.
or where we have to solve for the height.
But then go look at this section then. Remember that, let me go find you that section. You did solve problems. You did solve equations that had radicals where the variables were inside the radical, right? You're looking at section 7. You're looking at section 7.6. Let me write that down. See also, maybe 7.6 is a better section in that sense. See also section 7.6. Equations involving radicals. So let's see if there's anything I can see that's, super specifically like that. This one's got fancier, larger numbers, but you are solving for H, and H is inside the radical. So all the things that you used in section 7.6 are apply, and that sense, maybe section 7.6 is more relevant than 8.7. Here's one interesting one, 7.6, that you would eventually find out. Make sure I got my camera in the right place. Here's a couple problems from 7.6. Now, that seems to be somewhat simpler than the one you're looking at, but it is like the one you're looking at. That problem 55. Solve for H. They didn't give you a t-value. They want you to solve for H as a formula, but if they had given you a t-value and said solve for H, it would be similar to our problem, maybe, certainly a little bit easier. Let me write that one down. I'm running out of space, but I'll have to go to another paper. See problem 55 in section 7.6. I mean, let me ask you this, because it'd be very easy to demonstrate this problem. You think you could do problem 55?
Yeah, I believe so.
So, I mean, problem 55 looks like a much simpler version of what we're doing, but not horribly simpler. I mean, they give you the same steps, similar steps. Maybe our problem has a couple more steps.
Because for problem 55, you'd want to get the radical by itself, right?
Yep, that was the procedure.
Okay, thank you. Like I said, not trying to fish for answers.
No, that's
Sorry.
okay, but that's as close as I see in the book to that problem.
Thank you.
sign. Oh, sorry. I forget my microphone's on. I'm just sitting here doing other problems.
Hey, Professor.
Go ahead. Go ahead.
For number 4, would X be the price or would X be the profit?
Let's pull up number 4. Zoom, zoom, zoom. Bum, 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 bum. Let's share the screen. So, yeah, you were not told the names of any variables. You probably want to, I mean, having profit and price both start with P is funny. It might be safer to say price is X and profit is P. Yeah, you don't want to you don't want to say profit is capital P and price is little p. That would be hard to manage. So, and in terms of your equation parabolas, often you used X for the input for the horizontal variable. So I think using X for the price would be reasonable.
Okay. And my only other question, for dealing with such large numbers, can I just divide all the numbers by, let's say, 100,000?
You certainly could, and definitely in a graph, it's nice to say that, you know, like let's consider the axes to be millions of bacteria. So then the axes would be 1 million bacteria, 2 million bacteria, maybe. And so, you know, and you could then, if you're going to scale it, yes, you can scale it in different ways. You could say 750 thousands, 0.750 millions. No, that is definitely one way you can deal with large numbers, as long as you remember when you bring your answer or your graph that you point that out. You don't say well, the profit was $750 when it was $750,000.
All right.
So
Thank you.
yeah, that's a reasonable technique. Um, five. Hmm. Well, thank you for hanging out with me for these time, Jacob. And I hope I got any, questions settled. Is there any just before, and we still have several minutes, but just before we leave, is there anything else you're looking at you need help on?
I do have a few general questions. What do you, for number 4, what do you mean by C?
Let me look at it.
I'm just confused by the wording.
Let's pull it up. Got it. Got it. Let's share it. Oh, okay. So we're looking at it right now. So let's say that you find this parabola and that you draw it. Whether you look at the graph or whether you look at the formula you construct, does every price result in a profit? And I guess you could say a positive profit, but I understood profit to be you made money, you gained positive dollars. Does every price you set result in a profit, or are there some prices where you will not make a profit? And if you graph this parabola and if you have the right formula, you'll probably decide that not every price will produce a profit. So I was just asking specifically what prices would not produce a profit. You're not going to set the price at that level.
Okay, so it would be when the price would, or it would be below 0 then?
The profit would be below 0 or the profit would be negative.
Okay.
They'll, yeah, tell me where that happens because you want to avoid that.
All right, thank you. And for number 5, for C, you asked to make a sketch of the graph, but you didn't give any graph paper. Did you just want me to, or did you just want us to do a separate piece of graph paper?
Yeah, if I was being, I must have rushed that a little bit because ordinarily I would give you a graph paper. Now you can use your own graph paper. You can use a graph paper from my website, or you can just draw really carefully. But just to make your life easier, if you use graph paper, you'll do a lot better.
Okay. I believe that's all the questions I have.
Okay, well, you can always send me other ones later.
Hey, Professor. If I have 1 point that works but 2 that doesn't, would that mean that that 1 point that the graph may be correct, or how do I put this? I have 1 point that's correct, but I have 2 points that are not. Would that mean the whole equation is not right, or would that mean that just one part of the equation may not be correct?
Which problem are you talking about?
Number 4.
So you have an equation for a parabola, and one of those data points fits and the other two don't. That means you have the wrong parabola. Yeah.
Okay, so would that mean that the entire equation is wrong, or would that mean just part of it is wrong?
Pretty much the entire equation, because you want the perfect match. So if you don't have the match, it doesn't matter if it has 1 point right, all the other ones would be wrong.
Okay.
Yeah, so you have to work through your arithmetic and remember that. What was I gonna say? If you saw what we were doing on Tuesday, someone asked, I can't remember, it was Julie or someone asked about fitting a parabola through 3 points. So this is definitely what you're doing. It's just the numbers here make this work a little bit harder.
Okay.
So you're using the equation of creating 3 equations with 3 unknowns, trying to solve a system. Okay, I'm gonna cut this off and put the recording up for everybody and put these notes up for everybody, just in case anybody's scanning the website for extra notes later. So if you do have another question, of course, you can always send it to me.
All right. It's been a pleasure, Professor.
You have a nice day.
You as well.
Bye.